So here's our first model of the tangent galvanometer. We have a compass, we have the wire wrapped around it, and I've positioned the needle so that it's directly underneath those wires. Now when I hook up a battery to it, we see that the needle moves directly perpendicular to that coil of wires. And if I were to turn the battery around, once again we see the needle move, but in this case it has swung 180 degrees so that we now have the needle facing in the opposite direction. But the point is it is actually perpendicular to that coil of wire. Now here's my example of a larger demonstrator model for the tangent galvanometer. This is one that I would use to show to my students. It starts out with two batteries here and a battery holder. The battery holder has wires coming out of it, and just to make it easier to connect, I've attached alligator clips to the ends of each wire. The coil is actually wrapped around a clear plastic cylinder that was cut out of a 3-liter soda bottle. We take a look at it from the side. We can see the piece that I cut out is about maybe 3 inches wide. There's about 15 turns of wire around the outside of that, and the wire then comes out at the bottom and then goes over to a bolt that's been added to the base, the wooden base here. And as you can see, the wire comes out on this side, and there's also a second wire coming out on this side. And the alligator clips would attach to those bolts when I want to energize that coil. Now, inside then, whenever it's connected, we would get a magnetic field. So to show that, we can take a compass, and if we look very closely, I'm lining I'm turning it slightly so that the compass needle is directly parallel with the coil of wire. And if we watch very closely, if I energize the coil, once again we see it move perpendicular to that coil, which is showing the magnetic field direction. If I switch these around, and we touch it again, we see the compass move in the opposite direction. Here's my display model one more time. In this case, I've hung a bar magnet down from the top of the coil. It is parallel to the coil itself, and once again, if I energize this coil, we should see a movement. In this case of the bar magnet, it lines itself once again to the magnetic field, which is perpendicular to the coil itself. If I release it, it returns back to the center. If I were to switch my polarity around, switch my wires around here, we will see it reverse itself. Once again, it is perpendicular to the magnetic, or to the coil of wire, and it's lining itself up to the magnetic field.
Okay, here we go, 5 turns. Okay, we got 0 amps. Let's do clockwise or counterclockwise, who cares? Okay, we're going counterclockwise. Or excuse me, 1.02 amps. Turn the voltage down. Reverse the current. 0.71 amps. Ten turns. .49 amps. Reversing the current. .31 amps. Now 15 turns. .34 amps. .21 amps.